In this video we're going to be taking a look at the product rule. Alright, this would be for that beginning 1 calculus student, right as they are beginning to learn calculus and they're just getting into the derivatives. The product rule here I have outlined for you. Alright, the derivative of taking the product of two different functions, an f function and a g function. Alright, you're going to do this by using the formula, taking the original first function, multiplying it times the derivative of the second function, and then adding to that the second function multiplied by the derivative of the first function. Alright, now as a beginning calculus student, it really is good for you to show that you are taking the derivative as opposed to just automatically doing it in your head. So initially, I always introduce the ddx notation inside my derivative to indicate that you're going to take the derivative in the next step. Eventually, after you get better with this, you will leave that ddx notation out. Alright, so we're going to do about 3 examples here. This first example, f of x is equal to 2x plus 3 times the quantity 5x plus 4. So we clearly have two functions here. Okay, so I am going to set this up and indicate that I am taking the derivative, so f prime of x. Alright, now like I said, this first time I write it out, I basically am writing out the rule, and I'm going to use some ddx notation. So this says take the first function, which is 2x plus 3, and multiply that times the derivative of the second function. So I'm going to show ddx of 5x plus 4. So that's the first function multiplied by the derivative of the second function, plus the second function, which is the 5x plus 4, and then multiplied by the derivative of that first function, so ddx of the 2x plus 3. Alright, now basically in that line all I did was lay out the formula. Now on this line I'm actually going to take the derivatives. So this 2x plus 3 is going to stay. Then I'm going to take the derivative of this right here. Well, the derivative of 5x plus 4 is just going to be a 5. I'm going to keep that binomial in front, so 5x plus 4. And take the derivative of 2x plus 3 is just going to give me a 2. Alright, from here on out it's just straight algebra. To be able to simplify, you'll distribute the 5 and the 2. So we'll get a 10x plus a 15. And then again, another 10x plus an 8. Combining some like terms here, we'll end up with a 20x plus 23. Alright, so that one was just a very straightforward implementation of that rule, and then showing that ddx notation in that second line so that you make sure you have the formula correct. Alright, let's take a look at some other examples here. At this point, if you are learning the product rule, you have probably at least been introduced into the derivative of sine and cosine, so I thought I would go ahead and throw some trig functions in on these as well. Alright, now again here I've got two products. Alright, there's a little times sign in between there, so I am multiplying 3x squared, which is my first function, times sine x, which is my second function. So I definitely have product rule going here. So I'm going to tell the person that's grading my paper, I'm going to say, okay, hey, I'm starting my derivative, so y prime. I'm going to write the first function, which is 3x squared. And then I'm going to multiply that times the derivative of my sine, so ddx of sine x. Alright, plus that second function, which is sine x, times the derivative of the first, so ddx of that 3x squared. Okay, now in this line I'm actually going to do the derivative in there, so I'm going to have a 3x squared. Derivative of sine x is cosine. Hopefully at this point, like I said, you have that memorized already. Sine x for my first function there, and then taking it times that derivative right there would be a 6x. Alright, now from here, the rest of the way down, I'm just going to do some cleaning up. This 6x really needs to show up in front of that sine x, so I'm going to have a 3x squared cosine x plus a 6x sine x. Alright, now technically there is absolutely nothing wrong with that answer. That's a perfectly good answer for a derivative. However, specifically if you are in my class, alright, I'm going to request that you go ahead and factor out a greatest common factor if there is one, because later on when you start finding critical points and things of that nature, then you're going to have to factor it anyway. So if you practice that while you're learning your derivatives, it makes the future steps in calculus a little bit easier. So I'm going to take out a 3x. That's going to leave me with an x cosine x plus a 2 sine x. Alright, but like I said, technically either one of those answers are fine, all right, and just a lot of people will automatically factor out that Gray's common factor. All right, now for this last example we're going to look at, we've got y equals 2x cosine x minus 2 sine x. All right, I kind of did this on a reason, for a particular reason here. Here I've got the 2x times the cosine, all right, so definitely I've got a product rule that's going on right there. All right, now this over here is 2 times sine x. This is a constant. All right, now technically I could do the product rule right here, but if you stop and think about what you're doing in this second portion, you're taking the derivative of the first function. Well, if I used product rule on this is a constant. When I take the derivative of a constant, I get a 0. So while yes, you could do the entire product rule on this, all right, this whole term here after the plus sign is going to be 0, because when I take that derivative of a constant, it's 0, which is going to make this term 0. So there's no need to do the product rule on this, all right, because this is a constant. Looking at the difference here, this is not just a plain constant, this is a 2x. So product rule has to be applied here. Here, it does not have to. I could just, it's the constant multiple rule here, constant multiple rule. Kind of abbreviate that because I'm running out of room on the paper. Okay, so with that little discussion going on there, let's start here. We're going to do y prime. All right, now I'm going to go through product rule on this one. So it's going to be the 2x times the derivative of cosine, so d dx of cosine x. I'm probably going to, because of lack of room, I'm going to drop the parentheses from around that, and then plus the cosine x, and then the derivative d dx of that 2x. All right, so all of this is from the product rule there. Now the minus sign is going to come in, and then like I said, I'm just going to leave that 2 right there, and I'm going to do d dx of the sine x. Okay, all right, now in the next line, I'm actually going to take some derivatives here. So I'm going to have the 2x will be out in front. Derivative of cosine x, hopefully you have that memorized as negative sine x. All right, cosine x right there. Derivative of 2x is just 2. All right, and then let's keep going, minus this 2, and then the derivative of sine again is just going to be cosine x. So at this point, I have taken all of the derivatives, and I just need to go through here and clean this up. This right here, I've got a negative and a 2, so really my coefficient is a negative 2x here, so I would bring that negative out in front, negative 2x sine x. Again, this 2 right here, it kind of looks like you're trying to take the cosine maybe of x times 2, so we don't usually leave it there, we move it in front. So you're going to have a 2 cosine x, and then minus 2 cosine x. All right, at this point, hopefully you see that you've got some like terms, so those 2 are just going to cross out, which is going to leave you with just a negative 2x sine x for that derivative. Okay, so definitely 3 just real quick short examples of that product rule, and I made this video purposely for that beginning calc student that just needs to see some more examples or initially learn that product rule. Definitely thanks for watching. If the videos are helping, please share with your friends and let everybody know that they're helping you. Thanks.